a chassis, right? Number of ports. Maybe I have a switch. So we have 7, 8, some ports of switch. Let's assume I'm just taking example of a small organization. So in the small organization, all the pieces. Maybe here we have HR pieces.
Okay.
HR is connected, and again maybe a marketing
Okay.
connected, or maybe it's a sales are connected, right? So this
Yes,
is
yes.
HR, marketing, it's a sales. All the pieces are connected. Now
Okay.
this is a one broadcast domain, and moreover, this is a one organization. They may assign a same network range of IPs, right?
Yes.
Maybe for example, it is 10.1.1.1, it is 1.2, it is 1.3, 1.4,
Okay.
5, 6, like that.
Okay.
So what is happening here? Maybe here, this guy, HR guy, he's created one file, is sharing this. So this is the HR information. Who should receive?
Only HR
HR
department.
guy has to receive. Now what is happening? Everybody is connected through on a same switch, right? Everybody is connected through the same switch, and this is on same network. Now in switch by default, it is a one broadcast domain. One
Default
broadcast domain
VLAN.
by default. Default in a one switch, one broadcast domain. So one broadcast domain in the sense, this is in one network. Here it is, I said 1.6, 10.1.1.1.6, 1.5, 1.4 like that, right? Now your
Yes, sir.
sales guy or marketing guy, let's assume, is trying to access this shared file. Is it possible or not? Easily
Is
can
it
access.
that is possible?
Because it's a one broadcast domain. It's in same network. So
Okay.
this is possible. Now, where is the protection then? So as I said, HR, marketing. HR guy, whatever is sharing, only HR has to receive. Marketing guy, whatever is sharing, only marketing guy has to receive. Sales only, sales guy has to receive. So
Yes,
in
yes.
that scenario, maybe I need to change this IP address, or I need to use multiple switches. So HR one switch, marketing one switch, sales one switch. So again, it is cost is increasing. So we
Yes,
don't want
yes.
like that. Again, connectivity, everything. Instead of that, so to protect your LAN, we can go with VLAN.
Okay.
So what I'll do is here we'll create a multiple. Right now by default it's a one broadcast domain. Now we'll do what? We'll create a multiple broadcast domain. Maybe HR, I'll create it's a one broadcast domain.
Okay.
So maybe it's a sales, I'll create one broadcast domain.
Okay.
Maybe it is marketing one broadcast domain.
Okay.
So how do we create? With the help of VLAN. Now in a switch, there is a two-way we can create a VLAN. One is based on port number. One more is based on MAC address.
Okay.
So if you go with MAC address, it is very secure compared to port based on VLAN. But the thing is, you need to have a separate server.
Subnet.
Separate server. Server
Server,
is
server.
required to manage all the MAC address. Maybe this a MAC address is 0A, 0B. So we need to specify 0A is belongings to HRPC, 0B is belongings to HRPCs. Like that, you need a separate guy to manage this. And
Okay.
moreover, what happens? Maybe there is a faulty in the system. Maybe you are replacing this PC. Or maybe the card is, there is a issue with the NIC card. You are maybe changing that. The address will change. Maybe it will become 0x. MAC address is changing. Again, come back to the server. You need to change this MAC address. So a lot of
Okay.
things is there. It is again more secure, but the thing is, it is like you need to have a separate team to manage. You need to have a server. Again, management task will become more. And that's what we'll go with port based on VLAN. Very simple.
Sir, madam, can I ask one question?
Yeah.
In our company, while connecting the network guy will ask give me MAC address.
Oh.
What is the
That is
purpose
for the
we?
different scenario. Maybe to create the NAT.
Mm,
Okay, not for the VLAN. VLAN, no one will choose this. So because I'll tell you how the port based on VLAN will work, and I'll tell you. So this is
Okay,
not
okay.
required. MAC address based on VLAN is not required.
Okay, okay.
So now I will see this port number, right? Port number 1, port number 2. Which PC we have connected? HR PCs, right?
Yes.
Now I'll assign VLAN. Okay, I'll specify one number, maybe VLAN 10. And this is, maybe it's a VLAN 20. VLAN 20 is belonging to marketing. Maybe VLAN 30 is belonging to sales. Just an example.
Okay, okay.
Okay, this is VLAN 10. Again, port number 4, port number 5. Okay, this is belonging to marketing. And this is VLAN belongs to VLAN 20. And again, port number 7 and 8. So this belongs to sales. So VLAN 30. Okay.
Okay.
Now all these, see how it will work is, now we have shared, right? Now this guy, port number 1 is also VLAN 10. Port number 2 is also VLAN 10. So this guy is trying to access the shared file. VLAN 10 is trying to communicate with VLAN 10. See, port number 1 trying to communicate with port number 2. These are both are belonging to the same VLAN. So is able to access or not?
Able to access.
This is possible. Now, whenever the marketing or sales guy, see, whenever they're sending a request, along with the packet request, the VLAN also will be attached. So he's sending a request. Now he'll verify. My VLAN is 10. Your request from the VLAN 30. I don't know you. Immediately drop it. He will not allow to access.
Okay.
Okay. Now this is how the VLAN works. And here, if you come back to the port based on VLAN, moreover, the data center, right? So nobody have the access to enter to the data center side. And even if they enter, so they'll not come to know which port is and which VLAN and all. So that is the reason it is very simple to manage port based on VLAN.
Okay.
Not required MAC address based on VLANs.
Okay.
Okay. And here VLAN, if you see, so VLAN ID, it will start from VLAN, okay, ID.
Madam,
So
can I ask one
yeah.
more question?
Yeah.
See, if the in the one switch, as you said, there is a HR, there is a marketing, there is a sales. In all these departments, there will be many users. One switch will be not enough. Okay.
Yes, absolutely.
If we brought another switch, we should create same VLAN, or we can manage by.
No, you can create same VLANs. So I'll talk about that otherwise. Right.
Yes.
So you're asking about the trunking. Okay. Here. So total number of VLANs are 4095 VLANs.
Okay.
In this, the VLAN ID will start from 0, end with 4094. So including the 0, this is 4095. Now VLAN ID 0 and 4094, invisible. We'll use for voice over IP, we'll use for internal like that. Internally they'll use it. It's a hidden.
Okay.
So the VLAN ID will start from 1 to 4093 like that. So again, VLAN ID 1 by default, it is there. If you go to this switch, you just check it out. VLAN show command. Show VLAN. By
default, every port belongs to VLAN 1.
Every port, it's a VLAN 1. So we need to start VLAN ID from 2. We have to start. So while creating. Okay, now I'll come back your question. Definitely they'll use a multiple switches. Maybe in one cabinet, I may have HR PCs, I may have a marketing, I may have a sales. In another cabin, maybe same thing, I have a HR PCs, marketing, sales.
Okay.
Okay, this is HR and this is marketing and this is sales. And same thing here, HR, marketing, and this is sales.
Yes.
Now HR PCs, we have specified VLAN 10, marketing VLAN 20, and sales VLAN 30.
VLAN 30.
Here also we'll do what? It is in same office. Maybe it is in first floor, maybe it is in second floor, or maybe cabinets are different. We'll also create VLAN 10 for HR, VLAN 20 for marketing, VLAN 30 for sales. Now the question is, here I have some PCs, I have shared some file, right? Shared
Yes.
file. Now this guy, who can access? So these two PCs can access this shared file. And what about these two PCs? It's in switch 1 and switch 2. So what about switch 2, guys? Is it possible to access?
I think you, as you said, that need configuration.
Okay, I have a connectivity between these two.
Yes, if it is connectivity, then you can access.
That is, so here in the VLAN, there is a two kinds. One is we talked about the port. There is a two kinds of ports VLAN we can configure. One is access port and one more is trunk. Okay, by default, all the ports, whatever the port you have, right? These are all access port by default. Now access port, only one VLAN, one port, okay? In a port, we can configure only one VLAN. Okay, this is this port number 1, VLAN 10, port number 2, VLAN 10. I said, right? Port number 3, port number 4. It's a VLAN 20, VLAN 20. Now
Yes,
we'll
okay.
come back here. We'll come back here. So HR guy, this guy wanted to access the shared folder. Now he is sending a request. Maybe this port number 24, let's assume port number 24. Request is going through on port number 24. Now the question is, which VLAN you are configuring for this port? If it is a VLAN 10, only VLAN 10 traffic will move. If VLAN 20 is sending something, maybe here we have a shared file, marketing shared file. This guy wanted to access. Will it go through on this VLAN 10? It will not allow, no?
VLAN 10 should come to the HR only.
HR only. Then what should be the VLAN here? See, because this port 24, port number 24 is connected between these two switches, right?
Yes,
Which
yes.
VLAN this port has to allow? That is what we need to configure as a trunk. Trunk
Okay,
port.
okay.
If you enable trunk, so it will allow all the VLAN. All the VLANs. Or you can specify. So this port has to allow only VLAN 10 traffic, VLAN 20 traffic, VLAN 30 traffic. You can define that.
Okay.
So simply if you enable trunk port, instead of default it is access port, if you make it as a trunk port, it will allow all the VLANs.
Okay.
Okay, yeah. Now we'll talk about routing, right? So what is routing?
Routing is the interconnection to the network.
Okay.
To communicate between the router. It is called routing table, something.
Okay, good. So no need of any explanation, no? Then you know everything.
I know a little bit.
Okay, I'll just take an example of switch. For example, it is 10.1.1.1, it is 10.1.1.2, 3, it is 4. Okay, now maybe I'll make it as this a PC1, PC, okay, 4. Now PC1 wanted to communicate with PC4.
Okay.
Okay, this is a scenario. Now, whenever maybe he is having a shared file or something, so he wanted to ping or he wanted to test or he wanted to see the document, whatever it is. Now, whenever PC is sending a request, right, the PC1 will create one packet. This is called ICMP packet.
I see.
ICMP packet. In this, what is there in this packet? The source information. Whose source? Destination. Whose destination?
Receiver.
10.1.1.1, 10.1.1.4.
4.
And we have source port, destination port, whatever. Now, whenever switch, so switch is receiving this request, switch will do what? See, it will identify who is 10.1.1.4. So I said by default, it's a broadcast domain. So by default, he will do what? He will send the informations to everybody. Not the packet. He is looking for destination IP. Who is this destination?
4.
4. This guy will do what? He will create one more packet. Hey, you're looking for? Okay, source port is maybe. Okay, you're based on MAC address. I need to specify. Okay, this is A0. Maybe this is the D0. It specifies source MAC, destination MAC.
Okay.
Okay, source MAC is 0A. But we don't know the destination MAC. So switch will do what? Switch will send a request. Hey, I'm looking for destination MAC address. What is the destination MAC? And this guy is replying back, right?
Yes.
What is this? Source IP. Now, what is the destination IP now? Now, this guy is replying back. PC4 is replying back. So this IP is the source.
Who is the receiving end? It is the destination.
Now, what is the source MAC address?
The
D0. Destination MAC, it is A0. See, this is a source, right? 10.1.1.4 is a source.
okay.
Now, this is a port number 4, maybe port number 1, 2, 3, 4.
Yes.
Now, whenever this guy is sending a request, the request is reaching to the switch using port number 1. Now, switch is an intelligent guy. What this guy will do is, he is having some table. This is we called as MAC address table.
Okay.
Okay, MAC table. In this MAC table, okay, this guy is receiving some information through on port number 1. Port number 1. Okay. Port number 1 belongs to what is the MAC address? A0. Now, this guy is replying back to the switch through on which port number? Port number 4. Right? Port number 4. What is the source MAC address? D0. See, always he will mention in the table which address? The source address, source information, source port number, source MAC address. He will maintain like this MAC address table. Now, what is happening? So, whenever PC1 is communicating with PC4, he'll check it out. Is it in same network or different network? 10.1.1.1, 10.1.1.4, right?
The same network.
This is in same network. So, this is same network. Whenever the same network will communicate. Okay, these are all process will happen internally in the switch. So we'll start communicating. The next time, so when again he wanted to send some information from PC1 to PC4, he will not go through on this process because he's intelligent. He'll check it out. He's having a MAC address table. Okay, port number 1. What is the MAC address? Which port? So D0 MAC address. Port number is 4. So he will send the request directly. Whenever this is same network. Okay, if it is in same network. Now, if it is a different network, we'll talk about, I have a switch. So same thing, I have some PCs. Okay, now here I have a 10 network.
Okay.
So this is a 10 network, 10.0.0.0/24 network. Now same thing here. Maybe I have a different network. I have a one more subnet in my same office. I have another subnet. Maybe this is belonging to just an example 11.0.0.0 network.
Okay.
So now I have in between. So directly, instead of connecting directly, I have a router because it's a different network. If it is the same network, fine. But this is a different network. It's a 10 network. It's a 11 network. Now this guy 10.1.1.1 wanted to communicate with 11.1.1.1. So whenever he will do what? Whenever he is sending a request, it will create a packet. Who is the source? Who is the destination?
Uh, 10.1.1 is the source, and
Absolutely.
11 dot this one is the destination.
Okay, 10.1.1.1 is the source. Destination IP is 11.1.1.1. So whenever the packet is sending, it will check it out. Who's the source destination? So source is 10.1.1.1 and destination is 11.1.1.1. It will check it out. Is it in same network? Is it the same network?
There is this is different network.
Different network. Whenever there is a different network, so switch easily will understand. Okay, I cannot communicate internally. It's a different network. Now what he will do is, so he will look for default gateway. Default gateway. So what is a default gateway? It says that, okay, whenever you have a different network, you take somebody support. Whose support? We'll go with router.
Router.
Now router I have connected. Let's assume. Maybe one of the port, E0's port, E01 port. So here, I'll assign one IP address for this port. Maybe it is 10.1.1.100. Here, maybe 11.1.1.100. Now in the PC, we need to assign default gateway. Otherwise, if you don't assign default gateway, you are trying to reach to 11 network, even though if you have a router. So switch will do what? Whenever there is a request, it will drop. Because you don't have default gateway. So switch can communicate only the same network. Now here networks are different network. He will not help because it's a layer 2. Only the MAC address communication will do if it is the same network.
Okay.
Right?
Yes, yes.
Okay, now we need to do what? If you have a router, the router interface, right? We called as this a interface, this IP, interface IP. We need to assign as a default gateway. So my default gateway is 10.1.1.100. So it means that whenever if it is a different network, look for the default gateway. Simple, look for the default gateway. Now default gateway is what? Here, 10.1.1.100. So it says that it's my default gateway. Whenever there is a different network, the request has to reach to where? To the default gateway. Here. So in this router, we'll come back. Router also will maintain one table, routing table. What is there in the routing table? So these entries, Ethernet 0, Ethernet 1. What is the IP? Ethernet 0. 100, right? Ethernet 1, 11.1.1.100, right? Now, whenever you are getting it right, whenever there is a default gateway, switch will send a request to the default gateway.
Yes.
Now, in the router, you have Ethernet 0, Ethernet 1. So Ethernet 0 is 10.1.1.100. Ethernet 1 is 11 network. Now you're looking for which network? 11 network, right?
11.
Now we will check it out. Whenever the request is reaches to router, router will check the routing table. So I have a 10 network. From 10 network, I'm receiving a request. Do I have any 11 network? Yes, we have 11 network. In which interface? Ethernet 1. Now he will send. He will do what? He will do the hop. Hop in the sense one interface to another interface. He will send the packet.
Okay.
Then come back to switch. Switch function is what? He will look. You will identify, right? This IP. Which PC is having this IP? He will easily come to know. Okay, port number 1. Have this IP. Send this packet.
Okay.
So this is what the routing function. Now, okay, this is fine. We'll take another scenario. Let's assume I have one network. One network, it is Ethernet 0. I've connected with 10.1.1.100. Here we have a multiple PCs. We have a 10.0.0.0 network. Okay. Now I have another branch. maybe we have connected serially. So we have a WAN connectivity in between, or maybe one building to another building nearby. So we have connected. Just an example. Serially, we have connected. So maybe here we have a serial ports or WAN ports, something. We have another network. This is maybe 20.0.0.0 network /24. So the default gateway is, it is Ethernet 0, 20.1.1.100, just an example. Now again, we have connected router to router, right? Through on one interface.
Yes.
Here also we need to assign IP. So what is the IP will assign? Okay, we'll go with 15. 15.1.1.1. It is 15.1.1.2.
Okay.
Now this is in router 1. This is in router 2. Right?
Yes.
Now we'll talk about routing table. What about router 1 routing table? What entry we have? Ethernet 0?
Ethernet 0 and Ether
100, right?
100 and 20 dot
Then no.
100.
I'm talking about router 1. Router
Uh,
1 interface, it is Ethernet 0, 10.1.1.100.
100.
Serial port, it's a WAN connection, port 15. Only these two address we have in router 1, right?
Yes, yes, yes.
15.1.1.1.
Okay.
Router 2?
Router to 20.1.100 and 15 dot.
Absolutely. So 20, okay, I'll have a IP. 1.1.1, 100, serial 0/0. It is
15.1.1.1.2.
2. Yes, absolutely. Now the request here from the 10 network, we have one PC. 10.1.1.1 PC need to send some packets to 20.1.1.1.
Okay.
Now I have a default gateway. So PC is assigned a default gateway. The default gateway is 10.1.1.100. This is the default gateway. Okay. Now, whenever the request is reaches to switch will check it out. It's a different network. Okay, if it is a different network, do you have default gateway? What is the default gateway? It is 100. So
100.
request will move to here.
Okay.
Then router will do what? Router will check the routing table. Array, I have 10 network, but I
Yes,
want to
yes.
reach to where?
20.
right? Where is it 20 then? Array, I don't know. 20. Where is it 20? I have 10 and 15, but we don't know 20. He will drop this request. He will drop. Now, we want to communicate with 20, right?
Yes.
We do that. That is what we required a routing protocol. So we have two kinds of routing. One is static routing. One
And
more
dynamic
is
routing.
absolutely. You know any protocol?
Static and I know this much only. One manually, dynamic.
Yes,
DSP.
dynamic is automatic.
Yeah, automatic.
So dynamic using a protocol, protocol or OSPF. So EIGRP, it's a Cisco proprietary. So you have to use this. This is a static is manual. Manual in the sense, how you know? Right now, which network you want? 20, yeah?
Yes, yes.
We have to configure manually. Go to router 1, configure. So 20.0.0.0 have to connect. We have this 20 network where if I want to connect to 20 network, where I need to reach? From this router, the packet has to move till here. If you go to
Yes.
this router, you will get 20, right?
Yes, yes.
That's what we need to specify. 15.1.1.2, if you reach, you will get 20. This is static routing. You have to configure manually. We'll come back router 2. Static routing. So if I want to reach to which network?
10.100.
Okay. We can specify a network via which route?
By serial.
15.1.1.1, right?
Yes.
Otherwise, this serial port or IP, you have to specify. Now we will understand. So, okay, whenever the packet reaches, he'll check it out the routing table. He'll see this. Okay, whenever you'll see S, right? Okay, this is static routing. I need to reach, I will get 20 network if I go to this route.
Okay.
Okay, now he will do what? He will go to this route. He'll reach here. Once he reach here, router 2 will check the table again. Okay, there is a request for 20 network.